I'm giving this talk on behalf of Follmer and Hiroshi Ishii from MIT Media Lab Tangible Media Group. So today I'm going to talk about line. Line is a simple and a versatile form we encounter in everyday life. It is an everyday material for us like string, rope, or cables, and we have this specific the way it interact like a wrap or knot or bind. Line is also an expressive media since our ancestors started to use since back in like 30,000 years ago, or artists use wire or string to create aesthetics or conceptual form. And also currently on screens, we use 3D data are constructed often with lines such as wireframe, mesh, or vector data. Also, line has an interesting transformation capability where knitters create 2D or 3D shapes from a single yarn. So given this multiple characteristic of lines, how can these be woven into the design of shape-changing interface? With such kind of shape-changing interface, how can we design the interaction with it? In this project, LineFORM, we imagine a shape-changing material which consists of a single line and explore how we can interact with them through defining design space for display, interact, and constraint. So as a related work, there have been lots of passive line-based interface, and these are used for either manipulating 3D data with leveraging the lineness or applying to daily materials such as rope or cable. And even there's two papers coming in this year's UIST. And recently, shape-changing interface has been one of the mainstream in the field of HCI. And various topologies from solid surface to particles have been explored. There has also been few line-based interface proposed, but there are very specific applications for CAD, or hardware is either grounded or required really large cables. On the other than HCI, snake robotics has been an active research area. These serpentine robotics, composed with a series of 1 degree of freedom motors, were developed mainly only for inspection and locomotion. So comparing to this previous work, we propose this LineFORM Actuated curve interface, and we try to define the design space for the interface from the perspective of interaction design. And we introduce really the initial implementation based on the snake robotics technology. And with this prototype, we propose broad set of applications in different scenarios. And our intention of this paper or project is to inspire further research in the shape-changing, in the field of shape-changing interface using line. So I would like to start from the design space. So as a design space, we're defining how we can interact with this actuated curve interface. It can be used for displaying information or form. We can directly interact or manipulate with it, or it can constrain our motion. So as a display, using the transformation capability of line, it can create curve, surface, or solid. And utilizing this modality of transformation, line can represent different kinds of data representation. For example, graph or vector data, or it can represent iconic forms, more meaningful contextual form, or render some kind of user interface element so that user can manipulate it, or ergonomic shapes and which can fit to your grip of hand, or some kind of tactile feedback shape which can create this small texture to create different kind of haptic feedback. As an interaction part, we leverage the affordance of line as we use in the daily life. For example, we can deform the line just like a wire or rope, or we can touch along the line, or pinch using our 2 fingers. And also using the active feedback together, it can create variable stiffness so that it can provide user to manipulate in certain degree of freedom, or it can provide haptic feedback as user wrap around or wrist or according to the form. Lastly, as a constraint, it can give a certain freedom for user with line. You can either directly constrain your motion on body motion, or through some other objects, physical objects, such as tools. So as a whole, the actuated query interface has potential for designing interactions, and we demonstrate various applications and scenarios based on this design space. So before going to the application, I would like to quickly talk about our implementation. Here, to propose different various kinds of application, we implemented 2 scaled prototypes. And both prototypes are composed with a linear series of servo motor inspired by snake robotics research. These are the specifications for each prototype, and each has like different constructions such as 3D or 2D and different torque and resolution. And especially the larger one, because the servo motor itself has a daisy chain scheme, it can change the, it can detect the shape, it can get the sense feedback, and it can also change the stiffness by either changing the torque on, switching the torque on and off, or controlling the PID values of servo motor. And the overall system looks like this. The hardware is controlled by a software on a computer through a microcontroller, in this case Arduino. And the software we developed using a processing, and the software handles both the input and output. Please check the paper for more detail about the implementation. So, using this actuated query interface, what can we do? How can we use the computer or tools around us? First example is a mobile device. Using the functionality of Line, it can wrap around your wrist as a smart wristband or watch, and it can give you this active notification with haptic feedback, and it can also give you this static notification, passive notification, which provide you affordance of peeling off from your wrist. As you peel off from your wrist, it creates this 2D surface, rectangular surface, to give or either give information or touch surface. And once you get a phone call, it transforms into a phone shape. It can be both to be used as a representing functions through icon, and also physically covering your ear and mouth. Additionally, we also, in presentation, we use mobile device as a remote controlling slides, but we use static device. But having this LineFORM, it can transform from controller or stick device so that it can help you having a nice presentation. So a second application, I applied the transformation into daily line-based material, in this case, cable. First example shows a cable which can transform according to connected module. In this case, a lamp bulb, the cable creates a shape of lamp stand or even maybe shade, and the input handle to control the brightness. Also, because cables are used for transmitting data or electricity, this shape-changing cable can represent the invisible transmission between 2 devices. Also, using the notion of bandage or functionality of line to wrap around on your body, it can be used as a body constraint. By using the stiffness changing function, it can be some kind of dynamic shaped stiffness changing bandage which can be used for rehabilitation or training. But more importantly, more interestingly, using the capability of shape detection, it can also record users' motion and replay back or even synchronize in the real time. So people can learn kinetic motion from somebody else through their body, not visual or in sentence. And we believe this system is really significant in terms of the exoskeleton, because the form factor of line can adapt to any size of body. And as a smart ruler, it can support users to draw a line on top of physical paper with having the computational aid. Lastly, you can also imagine manipulating the vector data by your hand. And not only manipulating, but also you can have the computational support, such as rendering hinges or mirroring, or snapping to a certain degree or angle. So as a limitation in future work, there's lots of technical limitation right now for our implementation when we think about using as a real like mobile device or cables, such as power consumption, resolution, or torque. And for certain application, other actuation technique might be better. For example, when you want to wrap around your body, soft actuation such as pneumatic technology should be considered. And other properties such as thickness, texture, length, or color could be changed as well, and this can expand the design space of actuated curve interface. For example, if you can change the color or appearance of the line, it can be some kind of dynamic shape-changing display. We're also imagining future interaction techniques. For example, because lines or ropes or strings are used to bundle object, tie object, and connect object, we are thinking more using this actuated curve interface to interact with other physical objects as well as our hand. And another thing is, although we use only a single line for this paper for applications, we believe combining multiple lines would expand the application and the way we interact. For example, when we think about our clothes, it's all composed with string, and using multiple lines can create like a weaving and create a surface and such kind of thing. So as a summary or conclusion, in this paper, we propose line as a novel form for shape-changing interfaces and explore the design space from the perspective of interaction design. We utilize the transformability of the line to display different shape to create dynamic affordance and functions. We integrate the transformation to daily line-based material to provide seamless interaction in everyday scenario. We also propose to constrain our body motion with the form as adaptive exoskeleton as well. So, is this the end of the line? Actually, this is just the beginning, or this is just a very first step of our expression of actuated curve interface. So going further, there are still a lot of inspirations, notions, or technologies related to line in different scales and fields that can extend our design space and push our imagination for actuated curve interfaces. Biology, manufacturing, arts and design, or even cartoons and science fiction. Line is such a primitive but rich and ubiquitous medium. We envision the future transforming lines are seamlessly woven into our everyday lives. Also, this research was led by our group's vision, Tangible Media Group's vision of radical atoms, which foresee digital information to have dynamic physical form, and I believe the line would play a significant role to achieve this vision. So I would like to tie up my presentation here, and happy to get questions from audience. Thank you. Thank you.
wondering how small you can be.
So currently, we just use a commercial servo motor, and the tiny servo motor was the smallest one we could find, which was used for like a radio control, airplaning, wing angle changing, or whatever. But so for going further, I think we need to make one ourselves, and I think the hard point is to make the small gear, but we might want to challenge it.
I have a question for you. I know that your advisor is battling against the pixel empire, but have you considered putting displays in it or LEDs or something like that? Do you have any thoughts on that?
What do you mean? On top of?
Well, there's sort of, in shape-changing interfaces, there's kind of two categories, right? With and without display, but a lot of shape-changing work doesn't have a display because it's very difficult to integrate display, I think, technically.
So we also mentioned in the paper, but we are really interested in adding a display function, either by having small LED array or display or OLED display, or either projecting on it. So, and I think it has really dynamic transformation capability as a display.